Hey there, man, Alejandro. Welcome back for the 292 of me doing Daily LeetCode challenge. There's 1 year's worth of great contributions here on GitHub. Today's promise for May 4th, 2025. May the 4th be with you. And without further ado, let's get straight into it. Okay, there we go, LeetCode easy. Very nice. Problem 1128, number of equivalent domino pairs. Okay, so we're just going to be in a domino mode, okay? No worries. Given a list of dominoes of I is equal to AB is equivalent to dominoes of J is equal to CD, if and only if either A equals C and B equals D, or equals that is, one domino can be rotated to be equal to another domino. Return the number of pairs I and J for which dominoes of length and dominoes is equivalent to dominoes of J. What's the size? Okay, so it's O of n, so we do have to do that. Okay. Okay. Well, we can just probably use a hash map, right? Yeah. We can just sort all the dominoes, right? So make all the dominoes sorted in order and then keep track of them in a hash map, right? Here we'll say for A comma B in dominoes, small comma big is equal to A comma B if A is less than B, else B comma A, right? Put these in parentheses, chugga chugga, chugga chugga. And there we go, right? And now here we'll say D is equal to a default predictive int. And here we'll say D of small, comma big, plus or equal to 1, right? And now let's do printf string something like D. Just because I want to see. Right. So this will be 2, 1, and 1. So yeah, I'm gonna guess it's just for each one it's gonna be n times n minus 1 over 2, right? But because it's like the first one, and how many other pairs it can make, and that's gonna be the total plus that one. Yeah. But it's gonna be, yeah, the first one can make, yeah. So the first one can make n minus 1 pairs. So so for something like this, for something like 2, like right, let's say like that's n, then like, you know, let's say d of A comma B is equal to n, then the first one can make n minus 1 pairs, the second one can make n minus 2 unique pairs, third one can make n minus 3 unique pairs, plus dot 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 plus 1, which is equal to n times n minus 1 over 2, right? Because this is really like, the formula is like, you know, 1 plus 2 plus 3 all the way up to n is equal to n times n plus 1 all over 2, but here the last one is an n minus 1, right? So it's like this gets replaced with n minus 1, this gets replaced with n minus 1, n minus 1 plus 1 just cancels out to n, so that's why it becomes n times n minus 1 over 2, right? So here we can just say return reduce. So here we'll say map lambda n n times n minus 1 all over 2 dot values return sum of that, right? Yep, so that's accepted. Let's submit. And there we go. Bada bing, bada boom. Completion streak 292 days. Consistency is key. See ya tomorrow. 3MS beats 99.71% of solutions. We could probably do something easier. Instead of map, we can just do, we'll grab this, right? We'll do return sum of for n in d dot values. Right? And maybe that's a little bit faster. 7ms. Maybe if I don't make it a list. Yeah. I guess the map is fastest. Sure thing. Am I missing something here? Yeah. Okay, there we go. 3MS beats 99.71% solutions is exactly what we like to see. Okay, so nevertheless, as always in my videos, the quick recap of as I solve the problem. So here, essentially, we want to know how many pairs of dominoes are essentially the same, where a domino, whether you have it flipped upside down or not, is the same, right? So something like, you know, if you have the domino 5, 2 here, right, and you have the other domino here being like, you know, 2, 5, you know, these are the same domino, right? It's just that one is rotated while the other isn't, right? So what I did is essentially it's like, okay, we kind of want to put all the dominoes right side up, right? Like, you know, we want to find a way like, okay, how can I essentially make all the dominoes? It's like, you know, if two are the same, they'll both be like, you know, the same side. Well, how about for each domino is 2 numbers, right? For example, a 2 and a 5. And let's grab the small number and the big number. If they're the same, then they're the same, right? If you have 5 and 5, it doesn't matter which one is you pick as your small and big. It's 5 and 5, it's the same domino no matter what. Otherwise, let's arrange the dominoes. It's like, you know, we have the small number and the big number, right? So here what I do is for every single A, B in dominoes, I'm going to say small comma big is going to be equal to AB if A is less than B. Otherwise, it's going to be B comma A, right? So that way small will be the small number of the domino and big will be the big number of the domino, right? And they could be the same, who knows, right? It's just if they're not the same, then small will be the smaller number and big will be the bigger number, right? So that way I can essentially keep track of every domino as a pair of 2 numbers, where the first number is a smaller number if it is smaller, otherwise the same, and the second number is the bigger number, right? And then for every single, you know, small comma big domino pair, I'm going to augment its frequency in a frequency hash map by 1, right? So here I use a default dictive int. By default, the values will be 0, so frequency of 0 for anything. And then I'll be like, okay, grab the dominoes small and big value in that order, small and big, as a tuple, and augment that domino's frequency by 1, right? And then what I'm going to say is like, okay, for every single domino, we have its frequency, right? So it's like here we want to return the number of pairs ij of equivalent dominoes. Well, we know that every single key will represent, you know, some domino, and the frequency will be how many of that domino existed in the entire original dominoes array, right? Which means that if there are n domino that are the same, right? If you have n of the same domino, right? That means that the first domino is equivalent to n minus 1 other dominoes, right? And then second domino is equivalent to n minus 2 other dominoes. As it is equivalent to n minus 1 other dominoes, but we already had the first domino map with the second domino, so we're going to ignore that relationship with the second domino and make sure that we only get the relationship with the other dominoes, right? And then it's like, you know, the third domino, like, you know, this is going to be ditto, basically. This will be n minus 3, right? And so for essentially every single, you know, dot here, and eventually, you know, we get to 1, right? So for every single unique key inside of our dictionary, right, there will be a frequency of n, and so the total number of pairs that exist of equivalent dominoes will be n minus 1, right, plus n minus 2, plus n minus 3, plus dot, all the way up to 1, right? And here I'm just using a nice little mathematical formula. This is just equal to n times n minus 1 over 2. And the formula here is that if you have 1 plus 2 plus 3 plus dot plus n, then this is equal to n times n plus 1 over 2. So here's like, you know, having the 1 plus 2 plus 3 all the way up to n minus 1. So it's like taking this, right, and subbing n with n minus 1, right? If we sub in n with n minus 1, let's sub in this n with n minus 1, sub in this n with n minus 1. Okay, n minus 1 plus 1, that just cancels out to n. So here's like, you know, we have n minus 1 times n over 2. That's why we have n times n minus 1 over 2, right? So that's just a little formula, and that's essentially what we do. So for every single, so here what I'm doing is I'm looping through every single item in my dictionary. So for each key is a domino. We care about its frequencies, which is why I iterate over d dot values. So the frequency of every single unique domino in my dominoes array. I'm going to say, okay, I'm going to map each of these values, right? I'll have like a frequency of n, and I'll map it to n times n minus 1 over 2, because that'll be the total number of valid pairs that a domino created, right? The ij pairs inside of our dominoes array, right? So I'll map every single frequency in d dot values from n to n times n minus 1 over 2, because that'll be the total number of valid pairs. And then I'll do that for every single domino. So I'll take the sum of all those, and that way with the sum we have the total number of valid added j pairs, not just the total number of valid pairs for a single domino. Now we have it for every single domino. And there we go, bada bing, bada boom. That is exactly how I was able to solve this problem. And yeah, otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, in any form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.